Here, the question says, find the length of this line AC if this BCDE here is a square-shaped quadrilateral and this angle AEC is the vertex angle of the isosceles triangle ACE. So how can we solve this? How can we find the length of line AC? Well, let's first analyze this data given here. It says this shape BCDE here is a square-shaped quadrilateral. So what is a square-shaped quadrilateral? A square-shaped quadrilateral is a four-sided polygon with all its four sides equal in length and all four of its angles equal in size, that is 90 degrees each, because the sum of angles in a four-sided polygon is 360 degrees, and 360 degrees divided by 4 is 90 degrees. So that means all these sides here, BC, BE, CD, and DE are equal in length. Let's label the length of each side with X since they are equal. But here, you can see the surface area of this triangle CDE is 24.5 centimeters squared. If you look, this line CE is a diagonal of the squared BCDE. And we all know that the diagonal of a square always splits its surface area into two equal halves. That means this area here, 24.5 centimeters squared, is half the area of BCDE. Let's write it out. 24.5 centimeters squared equal to 1/2 area of BCDE. The formula for finding the area of a square is the square of the length of one of its sides. The length of its side we have here is x. So area of BCDE is x squared. Substituting here now, 24.5 centimeters squared equal to 1/2 x squared. To cancel the fraction 1/2, we multiply both sides by the reciprocal of it, which is 2. Now here we have 20.5 centimeters squared times 2 equal to 1/2 x squared times 2. 5.5 centimeters squared times 2 is 49 centimeters squared, and here 1/2 x squared times 2 is x squared. So 49 centimeters squared equal to x squared. To find the exact value of x, we find the square root of both sides. So now square root of 49 centimeters squared equal to square root of x squared. Square root of 49 centimeters squared is 7 centimeters, and here square root of x squared is square, so x now equal to 7 centimeters. Let's substitute it here now. Going back to the second data given here, that this angle AEC is the vertex angle of this isosceles triangle ACE. An isosceles triangle is a type of triangle with two of its sides to be equal in length, and the vertex angle is the angle the two equal sides make with each other. That is, this side AE and this side CE are equal in length each. Let's label them P each. So what is the value of P now? We don't know, but from this triangle here, since we have the length of this side and this side here to be 7 centimeters each, we can use the Pythagorean theorem. By Pythagoras, the square of the hypotenuse of the right angle triangle is equal to the sum of the squares of the two other sides. The hypotenuse is the side facing the right angle, which is this side P here. So substituting into this formula, P squared equal to 7 squared plus 7 squared. 7 squared is 49. 49 plus 49 is 98. So P squared equal to 98. Finding the square root of both sides now, square root of P squared equal to square root of 98. Square root of P squared is P, and here square root of 98 is 9.8995, approximately equal to 9.9. So P equal to 9.9 centimeters. Substituting here now, from this triangle here, since we have the length of two of its sides, if we have the sides of the angles, we can use it to find the length of line AC here. So what are the sides of the angles? Here, if you look, this angle here and this angle are lying on the same straight line, and we know that the sum of angles on a straight line is 180 degrees. So since this is 80 degrees, this must be 180 degrees minus 80 degrees, which is 100 degrees. Here if you look, since this line CE bisects the square, this angle also, which was initially 90 degrees, was also bisected by line CE to 45 degrees here and 45 degrees here. From this triangle, since this is 45 degrees and this is 100 degrees, this must be 180 degrees minus 100 degrees minus 45 degrees, because the sum of angles in a triangle is 180 degrees. 180 degrees minus 100 degrees minus 45 degrees is 35 degrees. and we have the size of the vertex angle. What is left now is the size of the base angles. Like we all know, the base angles of an isosceles triangle are equal in size each. That is, this angle here is equal to this angle. Let's label them y each. Now, still based on the rule that the sum of angles on a triangle is 180 degrees, let's sum of the angles of the triangle and equate them to 180 degrees. Summing up now, y plus 35 degrees equal to 180 degrees. Y plus y is 2y, so 2y plus 35 degrees equal to 180 degrees. Subtracting 35 degrees from both sides, now 2y equal to 180 degrees minus 35 degrees. 180 degrees minus 35 degrees is 145 degrees, so 2y equal to 145 degrees. Dividing both sides by 2, here 2 cancels 2, and here 145 divided by 2 is 72.5. So y equal to 72.5 degrees. Substituting here now, since we have the size of the angles of the triangle, we can use the sine rule to find the length of this line AC. Using sine rule now, line AC over sine 35 degrees equal to 9.9 over sine 72.5. Making line AC the subject, line AC equal to 9.9 over sine 72.5 times sine 35 degrees, which if you press your calculator equal to 5.954, approximately equal to 5.95. So line AC equal to 5.95 centimeters squared approximately. This here is a very simple question. We are asked to find the surface area of this triangle ACD highlighted in yellow color and the length of this line AD. And here we are given the volume of the cube to be 512 centimeters cube. We know that all the sides of the cube are equal in length, and the formula for finding the volume of a cube is the length of one of its sides raised to power 3. So let's label the side x each, since they all are equal in length. That means the volume of the cube using this formula here is x cubed. Equating x cubed to 512 centimeters cube, we have x cubed equal to 512 centimeters cube. To find the exact value of x, we find the cube root of both sides. Now cube root of x cubed equal to cube root of 512 centimeters cube. Cube root of x cubed is x, and here cube root of 512 centimeters cube, if you press your calculator, is 8 centimeters. So x equal to 8 centimeters. Substitute here. Now if you take this area now, it's a square because the sides are equal in length. So since this is a right angle here, we can use the Pythagoras theorem to find the length of this line AC here. By Pythagoras, the square of the hypotenuse of a right angle triangle is equal to the sum of the squares of the two other sides. The hypotenuse is the side facing the right angle, which is this side AC here. So using this, line AC squared equal to 8 centimeters squared plus 8 centimeters squared. 8 centimeters squared is 64 centimeters squared. 64 centimeters squared plus 64 centimeters squared is 128 centimeters squared. So line AC squared equal to 128 centimeters squared. To find the exact value of line AC, we find the square root of both sides. Now square root of line AC squared equal to square root of 128 centimeters squared. Square root of line AC squared is line AC, and here square root of 128 centimeters squared is 11.3137, approximately equal to 11.31 centimeters. So line AC equal to 11.31 centimeters. Substituting here now, back to this triangle ACD, let's draw it out here. To find its surface area, since the formula for finding surface area of a triangle is half base times height, in the case of a right angle triangle, any of the two sides that are perpendicular to each other can be taken as the base or the height. Let's say this is the base and this is the height here. We have base now equal to 11.31 centimeters and height equal to 8 centimeters. Substituting into this equation here, area of triangle ACD now equal to 1 over 2 times 11.31 centimeters times 8 centimeters, which if you press your calculator equal to 45.24 centimeters squared. So we found the area of triangle ACD to be 45.24 centimeters squared. Coming back to line AD, how can we find its length? Let's still use the Pythagoras theorem. Like we already said earlier, The hypotenuse is the side facing the right angle in the triangle. And here, this line AD is the side facing the right angle. That means line AD is the hypotenuse. Substituting into this formula, line AD squared equal to 11.31 centimeters squared plus 8 centimeters squared. 11.31 centimeters all squared is 127.9161 centimeters squared, and 8 centimeters all squared is 64 centimeters squared. 127.9161 centimeters squared plus 64 centimeters squared is 191.9161 centimeters squared. So line AD squared equal to 191.9161 centimeters squared. To find the exact length of line AD, we find the square root of both sides. Now line AD squared equal to square root of 191.9161 centimeters squared. Square root of line AD squared is line AD, and here square root of 191.9161 centimeters squared is 13.8534, approximately equal to 13.85 centimeters. So line AD equal to 13.85 centimeters. Thank you for watching. We found the area of triangle ACD to be 45.24 centimeters squared and line AD to be 13.85 centimeters in length. Okay, let's interpret it since it's not given in statement. Here, this indicates that the stuff in question is this yellow colored area here. That is the surface area of this triangle here. So how can you find it? We at least need the length of its side. The angles of this triangle here we can see are represented by A, B, and C. So since we know that the sum of angles in a triangle is 180 degrees, we can sum them up and equate them to 180 degrees. Now summing up, we're going to have A plus B plus C equal to 180 degrees. But here, the values of A, B, and C are given to be 5x, 4x, and 3x. So if we substitute them here now, 5x plus 4x plus 3x equal to 180 degrees. 5x plus 4x plus 3x is 12x. So 12x now equal to 180 degrees. Dividing both sides by 12, now 12x over 12 equal to 180 degrees over 12. Here, 12 cancel 12, and here 180 degrees divided by 12 is 15 degrees. So x now equal to 15 degrees. Coming back here, if you substitute x equal to 15 degrees, A equal to 5 open bracket 15 degrees, B equal to 4 open bracket 15 degrees, and C equal to 3 open bracket 15 degrees. 5 times 15 is 75, 4 times 15 is 60, and 3 times 15 is 45. So A equal to 75, B equal to 60 degrees, and C equal to 45 degrees. So you can just come back here, substitute that A equal to 75 degrees, here B equal to 60 degrees, and here C equal to 45 degrees. So from this triangle now, since we have the length of this side here and the sizes of its angle, we can use the sine rule to find the length of this side here. Let's label it P. Now applying the sine rule, P over sine 45 degrees equal to 8 over sine 60 degrees. Making P the subject, we multiplied both sides by sine 45 degrees. Now P over sine 45 degrees times sine 45 degrees equal to 8 over sine 60 degrees times sine 45 degrees. Here, sine 45 degrees cancels sine 45 degrees, and here 8 over sine 60 degrees times sine 45 degrees, if you press your calculator, is 6.5319, approximately equal to 6.53. So P equal to 6.53 centimeters. Substitute here now. Now from this triangle here, since we have the length of this side here, if we have the size of its angles, we can use the sine rule to find the length of the other sides. So what are the sizes of the other angles? We don't know. But if you look here, this is indicating that this side here is lying on the x-axis and this here on the y-axis. The x-axis is usually used to represent the horizontal axis and y to represent the vertical axis on a 2D plane. And we know that the angle between the vertical axis and the horizontal axis is always a right angle, which is 90 degrees. So that means this angle here is a right angle. So since this is 60 degrees, this must be 90 minus 60 degrees, which is 30 degrees. And here, if you look, this angle and this angle here are lying on the same straight line. And we know that the angle on a straight line is 180 degrees. So since this 75 degree, this must be 180 degree minus 75 degree, which is 105 degree. Now from this triangle here, since this 30 degree and this 105, this must be 180 degree minus 30 degree minus 105 degree, because the sum of angles in a triangle is 180 degree. 180 degree minus 30 degree minus 105 degree is 45 degree. So now, since we have the sizes of the angles, we can apply the sine rule to find the length of this side here. Let's label the sides A, B, and C. Applying the sine rule, A over sine 105 degree equal to B over sine 45 degree, which equal to C over sine 60 degree. But B is 6.53 centimeters. Now taking only this side here, A over sine 105 equal to 6.53 over sine 45 degree. Making A the subject, A equal to 6.53 over sine 40 all multiplied by sine 105, which if we press your calculator equal to 8.92 approximately. So A equal to 8.92 centimeters. Substitute here now. Coming back to this part here, 6.53 over sine 45 equal to C over sine 30 degree. Making C the subject, C equal to 6.53 over sine 45 all multiplied by sine 30, which if you press your calculator equal to 4.62. So C equal to 4.62 centimeters. Substitute here now. Now since we have the length of the sides of the triangle, we can apply the Heron's formula to find the area of the triangle. By Heron, if the length of the sides of a triangle are represented by A, B, and C, the area of the triangle must be equal to square root of S times S minus A times S minus B times S minus C, where S equal to A plus B plus C all over 2. Now from here, A equal to 8.92 centimeters, B equal to 6.53 centimeters, and C equal to 4.62 centimeters. Substituting here now, S equal to 8.92 centimeters plus 6.53 centimeters plus 4.62 centimeters all over 2, which is 10.035 centimeters. Now substituting all the values here now, A equal to square root of 10, which if you press your calculator, it's approximately equal to 14.57 centimeters squared. So area now equal to 14.57 centimeters squared approximately. So we find the area of this triangle to be centimeters squared, which is the yellow colored portion we are asked to find its area. Thank you for watching this video. Please tell us what you think about this video in the comment section, and don't forget to subscribe to this channel.